Hello, this is Beth Dixon, and we are doing the final review for Math 0030, and we're up to problem number 11, and hopefully we'll start moving a little bit faster. We seem to be getting about 2 problems per video. Hopefully that will speed up a little bit, but we'll just take it as it comes. Okay, so the next set of problems are perform the indicated operations and then simplify. And as we look at these are our addition, subtraction, distributive, multiplication problems, working with our polynomials. So one of the things that you'll want to be careful on the exams, these problems will be mixed just like they are here. So how do we tell what we're supposed to do? It doesn't say add and give us a set of addition, subtract and give us a set of subtraction, use distributive and give us that, use FOIL and give us a set of those. We have to be able to tell the difference. So as we look at these, let's be very careful at noticing some of the differences. Let's look at A versus G. In A, we have a binomial, 2 terms. Then we have 2 terms, but in between them is the addition sign. In the letter G, we have 2 terms, parentheses and 2 terms, but notice there is no parentheses. There's nothing in between the parentheses. That indicates that this is an addition problem because there's an addition sign between them, and this is a multiplication because there is no operation sign between the 2 parentheses. 2 parentheses next to each other indicate multiplication. In this problem here, we have a squared, so that means we will multiply that parentheses by itself. In this problem here, we have a number in front of a parentheses, which also indicates multiplication. In this problem here, we have a single item in front, and then a subtract, and then a 2, but this 2 is in front of a parentheses. So that indicates that we will multiply, but then we have something that we will add and subtract. So we have to look for those context clues as we do these problems. So we'll look at that as we go along here. So let's look at the first one here, and it is 7y minus 5 plus, in parentheses, negative 5y minus 13. Remember with an addition that does not change any signs, so you can either go on and add, or you can rewrite it dropping your parentheses, which is what I'm going to do for emphasis. And then we're looking for like terms. In this case, our 7y and our negative 5y are like terms, and 7 minus 5 would give us 2y, and negative 5 and a negative 13, because they're both negative, would mean we add those 2 terms and keep the same sign and give us minus 18. In the next problem, we have 8 times x plus 8, and that 8 is in front of the parentheses, and that means that we're going to use distributive. That 8 is multiplied by both parts of the parentheses. That groups the next, and it says 8 is multiplied by the next item, and that item is that. So that would be 8 times x and 8 times 8. So that would be 8x, and 8 times 8 is 64. There are no like terms, so we are finished. In the next problem, we have negative 9x to the 4th, parentheses, 10x to the 6th, minus 3x to the 3rd. And so what we're going to do again is distributive, because that indicates multiplication with something directly in front of the parentheses. So I'm going to multiply that first term through and distribute it through all of the terms in the parentheses. So that would be -9 times -10. And when I do these, I try to keep it so that I know that I'm keeping up with all the parts. So I generally do my sign first, then my numbers, then my variables. So I've got sign, number, and then my variable. And that way I don't leave out any part. I don't forget to do any part. So a negative times a positive is a negative. 9 times 10 is 90. There are x's, and I have 4 plus 6, so I have a total of 10 x's. Then I'm going to do -9 x to the 4th times -3 x to the 3rd. So that's negative times a negative is a positive. 9 times 3 is 27. Then that's 4. How many x's do I have? I have x to the 4th and x to the 3rd. So that would be x to the 7th. In the next problem, it says 5x minus 9 in parentheses squared. Remember, what that means is everything in the parentheses is squared. Squared means multiplied by itself. If I have 2 squared, that means I have 2 times 2. If I have 5 squared, that means I have 5 times 5. So if I have 5x minus 9 squared, that means I have 5x minus 9 times 5x minus 9. In this case, we can't use a simple distributive, but we use the distributive property, and we most of the time use the initials FOIL to help us to remember how to use that distributive. We're first going to multiply the first of this parentheses, which is that 5x, and do the first, then the outside, then we're going to move to the -9 and multiply again by the first and then the last. But this right here would be the inside terms and then the last. So we're taking this 5x and distributing it, and this -9 and distributing it, and that makes for the first, outer, inner, and last terms. So that's 5x times 5x, which would be 25x squared, 5x times -9, which would be -45x. Then I'm going to do these inside, that -9 times 5x, which would be also a -45x. And then I'm going to do these last terms. And that would be a -9 times a -9, which is a positive 81. And so that gives me 25x squared minus 90x plus 81. Notice as I do these problems as well that I could put some of this in the calculator. In other words, if I needed to go 5 times 9, and I may have to get up and get a new battery. Thought I'd charge this before I come home to do these, but apparently I need new batteries on this one, so I may have to go grab another calculator. But I could put that in the calculator, but I cannot put x's in the calculator. So don't try to do these on the calculator. In this next problem, this 2 is distributed to both terms. But notice we're going to distribute the -2. So this is going to give us the 6x, and it will sit out front. And then a -2 times a -5x gives us a negative 10x, and then a negative 2 times a negative 9 gives us a positive 18. A negative times a negative is a positive. Then 6x minus 10x is a negative 4x. 6 subtract 10 would leave us negative 4x, and then the 18 has no like terms. Notice on the next one that we have a subtract in between these, so this would not be a FOIL, where this one is an add, this one is a subtract. And as we do the subtraction, what we want to remember here is that when we subtract, we will change the signs of what follows the subtract sign. This is adding the opposite, the same way as we learned our subtraction. So this would be 3x subtract 5. Inside, that's a positive 6 and a negative 7. So when I subtract, that becomes a negative 6 and a positive 7. And now I can add my like terms. 3x minus 6x would be negative 3x. Negative 5 plus 7 would make it a plus 2. In the next one, I have a 5 in front of a parenthesis, so that indicates a multiplication. 5 times 3 would be 15. 5 times a negative 2y would be a negative 10y, having trouble multiplying. And then the plus 4y does not get multiplied. That end parentheses here stops the problem. So I have 5 times 3 minus 2y plus 4y. That 5 times 3 gives me 15. The 5 times negative 2 gives me negative 10y, then plus the 4y. Then I will add like terms. That gives me 15. Then negative 10y plus 4y. Negative 10 plus 4 would give me negative 6y. Okay, letter G would be x plus 12 times x minus 12. And I know it's times because the two parentheses are right next to each other. And so that would give me, again, multiplying x times x, which would be x squared. Then x times the last term, which would be my outside terms, which would be minus 12x. Then the positive 12 gets multiplied by both terms. The first one, which would be positive 12x, a positive 12 times x is a positive 12x. And then that positive 12 times the negative 12 for my last terms, which would be a negative 144. Notice in this case where I multiply the x plus 12 times the x minus 12, that gives me a plus 12 and a minus 12 in the center, and they cancel each other out. A negative 12x and a positive 12x add to 0. And so that then leaves me just the x squared minus 144, which is a special case of the multiplication. In the B part, we have 3 and 3, but there is a plus in between. And because it's a plus, it is an addition. And this time, I won't rewrite it. I'm just going to look for like terms. Again, for addition, we can rewrite it. You can rewrite it so you've combined your like terms. Or in this case, I think I'll even rewrite it, but I'm going to rewrite it this way. I'm going to write the 8x squared underneath the 5x squared, the minus 7x under the negative 8x, and the plus 5 underneath the plus 11. Notice none of my signs changed. Then we're going to add. That gives me 13x squared minus 15x plus 16, because none of your signs change. Letter I, says 6 minus 2 times 5x minus 3. Again, that 2 is multiplied because there is no operation sign between the 2 and the parentheses, which implies multiplication. So we'll drop down the 6, multiply the 2 times 5, which is 10x, then multiply the negative 2 times the negative 3. Let me move that up so you can see that. The negative 2 times the negative 3 to get a positive 6. Then we have 6 plus 6, which is 12 minus 10x. Do not let that negative confuse you. That negative goes with the 10. This 6 is a positive. This 6 is a positive. 6 plus 6 gives you 12. In letter J, we have 6y minus 1 and 2y plus 7. And so we're going to multiply those. And so that would be 6y multiplied by both, 6y times 2y to give you 12y squared. 6y plus 7 gives you plus 42y. Then we have negative 1 times 2y, negative 1 times 2y, which would be minus 2y, and negative 1 times 7, which would be minus 7. That then gives us 12y squared. 42y minus 2y would be plus 40y minus 7. And that's how we would use our FOIL to multiply that last letter there on number 11. Let's look at number 12. Number 12 says write the number in standard notation. And this is 5.687 times 10 to the negative fifth. Because it is a negative exponent, that means this number will be getting smaller and the decimal will move to the left. And because I'm going to be moving it to the left, I'm going to add a whole bunch of zeros here. I'm not even really going to count, I'm just going to add a whole bunch. But I know that it needs to move 5 places. So as I move that, I'm going to go 1, 2, 3, 4, 5 places. And so I will have a leading 0 and 1, 2, 3, 4 zeros, then the 5, 6, 8, 7. And that's how I would write that. Now, I didn't count how many zeros. I just made sure I had more than enough so that I didn't have to add them. Some teachers will just make the little loops here in places and then fill in the zeros. Some people just count and do it. This is how I do it, however you have it. I also remember that a negative number is going to give me a number much smaller than 1, and a positive number gives me a number much larger than 1. In the next problem, we have write the number in scientific notation. So I'm going to have a number times 10 to a power. And I know by looking at a number, and I said this in an earlier video, that if there's not a decimal, the decimal occurs at the end. If I move it anywhere else, it changes the value of the number. So if it's at the end, how many places do I need to move it so that the decimal has 1 digit left in the front? Well, that means I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. If I moved it 10 places, that would move the decimal so that there's 1 digit in front of the decimal. If I left it anywhere else, there would be more than 1 digit. If I moved it 11 places, there would be no digits. I want a number when I'm through that's more than at least 1, and less than 9.99999. It's got to be less than 10. So if I leave it at 45, it's too big. If I leave it at 0.5 or 0.45, it's not large enough. So 4.5 is a number between 1 and 10. So I want a number between 1 and 10. And at that point, we've now reached about the 20-minute mark, give or take. And so I'm going to conclude with problem number 13. And when we come back, we'll look at on how to evaluate and write the results using scientific notation. And so if you need additional help, feel free to contact me at beth.dixon@ws.edu. Thank you.